a sequence is given by the recurrence relation u to the n plus 2 is equal to 4u to the n plus 1 minus 3u to the n, with u1 equal to 4 and u2 equal to 11 for n greater or equal to 2, prove that the general formula for the sequence is un is equal to 7 times 3 to the n plus 3 divided by 6. So we've got u1 is equal to 4, u2 is equal to 11, and u to the n plus 2 is equal to 4 times u to the n plus 1 minus 3 times u to the n. Right, so what we've got to prove is un is equal to 7 times 3 to the n plus 3 over 6. So we've got to prove true for n is equal to 1. So if we make n u1, so u to the 1 is equal to 7 times 3 to the 1 plus 3 plus 6. So that becomes 7 times 3, which is 21, plus 3, which is 24, over 6. 24 divided by 6 is 4, which is what we wanted u1 to be. And therefore, true for n is equal to 1. Next, we need to now assume true for two values. N is equal to k and n is equal to k plus 1, because we've got two values to put in our recurrence formula relation. So uk will be equal to 7 times 3 to the k plus 3 over 6, and uk to plus 1 will be 7 times 3 to the k plus 1 plus 3 over 6. And then we got to prove true for n is equal to k plus 2. So u to the k plus 2 will be 4 times u to the k plus 1, so we'll substitute that in there, minus 3 times u to the k, and we'll substitute that in there. So just going to another page. So u to the k plus 2 will be 4 times 7 times 3 to the k plus 1 plus 3 over 6. Substituting that one in. Minus 3 times 7 times 3 to the k plus 3 over 6. Substituting this one in, that's u to the k. Right, the target is to get to 7 times 3 to the k plus 2 plus 3 over 6. So we're going to work down there until we get that. So this is going to be the target. Okay, right, so multiplying by 4, we get 4 times 7, which is 28, times 3 to the k plus 1 plus 12, minus 3, minus 21 times 3 to the k, minus 9. Don't forget we've got a minus sign here. And this is all over 6 because we've got the same denominator in both. Okay, so it's going to give 28 times 3 to the 3 to the k. 3 to the k plus 1 is the same as 3 to the k times 3. So we separated it up there. 12 minus 9 is 3. And we've still got minus 21 times 3 to the k, and that's over 6. So 3 times 28 is 84 times 3 to the k. Plus 3 minus 21 times 3 to the k over 6. 84 lots of 3 to the k minus 21 lots of 3 to the k gives me 63 times 3 to the k plus 3 over 6. Now, that 63 is 7 times 9. 9 is 3 squared. So this 63 will become 7 times 3 squared times 3 to the k plus 3 over 6. And then 3 squared times 3 to the k will become 3 to the k plus 2, what we wanted. We got the 7, we got the plus 3, and we got the 6. So we have achieved the k plus 1 version of the formula. Don't forget then to write down the conclusion. So the result is true for n is equal to 1, and if it's true for n is equal to k, then it's also true for n is equal to k plus 1. Just going to correct myself. So if it's true for n is equal to k and n is equal to k plus 1, it is also true for n is equal to k plus 2. Therefore, the result is true for all z plus for n greater or equal to 2 by the principle of mathematical induction. Okay, so this has been a video to prove a general formula of a sequence. I hope you've understood, and I thank you very much for watching.